Hi, everybody. Let's do IXL add vectors. Okay, so here we see the vector C, and here we see the vector D. They have already been attached head to tail. And so to find the sum C plus D, all we would need to do is draw a third vector from the unconnected tail to the unconnected head, just like that. Now, the components of this vector, which is C plus D, would be 2i plus 4j, or in the angle bracket notation, 2, 4. And when the vector starts at the origin, like it does in this example, then these components over here are just going to be the coordinates of where the head is. So 2, 4. But really, the components refer to how long the vector is horizontally and how long it is vertically. So really, these components mean that the vector is 2 units long horizontally and 4 units long vertically. If it had been over here, well, I didn't do that well. If it had been over here, then the components of this vector would still be 2, 4, even though the coordinates of the head are not at 2, 4. But when the vector starts at the origin 0, 0, then the components will just be the same as the coordinates of the head, even though that's not really what you're going to be looking for all of these problems. Okay, so this one over here, let's draw tail to head like that. Okay, and we can see that this vector is 1 unit long horizontally, and it's moving to the right, so that would be a positive 1. And it is 8 units long vertically and moving up, so that would be a positive 8. Okay. And since it does start at the origin, the head is also at 1, 8, but that's not always going to happen. So you're not always going to just be looking for the coordinates of the head, but when the vector starts at the origin, then these coordinates will be the same as the components of the vector. Okay. Now we're going to have some negative numbers. Just go like that. Okay. Since this vector does start at the origin, we can simply look at where the head is and find the coordinates of the head. That would be -7, -8. And those numbers would be the same as the components of the vector. Oops. I should say -8. All right, let's go ahead and skip a level here. If S is 5, 6, and T is 9, -4, find the sum S plus T. Okay, so we're just going to add them component by component. So 5 plus 9 is 14. You know what? Let me go back for a second. I thought that I was going to be able to get some problems where it didn't start at the origin, so I could show you that. Oh, okay, good. Okay, good. So this is a different kind of a problem. Here we can see that they sort of drew this in a confusing way. You might think that that you should draw a vector from here to here, but that would be incorrect. Or maybe the other way, from here to here. That would also be incorrect. Because these vectors should be connected head to tail in order to add them, not tail to tail like they are here. So they drew this one in a tricky way. What you need to do here to do B plus C is you're going to take C and attach the tail of C to the head of B. Okay. I'll do it in orange, like this is an orange. And then let's see. So this is, the components of this are -2, -7. So I need to make sure that when I draw this vector on B, I'm going 2 spaces to the left and 7 spaces down. So I would end up over here. Okay, I went 2 spaces to the left and then 1, 2, 3, 4, 5, 6, 7 spaces down. Okay, so now, right, this is vector, this and this are the same vector. Okay, even though they're in different places, they're the same if the magnitude and the direction are the same. So these vectors are the same. So we're still adding B plus, we're adding B plus C here. We just have to now draw a third vector from this unconnected tail to this unconnected head. And what would well, since this does start at the origin, then we can just look at the coordinates over here, which is -7, -1. All right, but really when we talk about the components, we're talking about not where the coordinates of the head are, but how far is it moving horizontally, how far is it moving vertically. So for this vector over here, it's moving 7 spaces to the left, so that would be -7 for the horizontal component, and 1 space down, so it's -1 for the vertical component. Even if this vector had been, let's say, over here, I hope I do this right. Let's see. Even if this vector had been over here, the components would still be -7, -1, because it still is 7 spaces to the left horizontally and 1 space down vertically, even though the head is not at these coordinates. All right, but if the vector starts with the tail at the origin, then the components are simply going to be the same as the coordinates. Okay, so let's move on now. W plus X. Okay, so again, it's writing this in this confusing way here. What we really want to do is take X and attach the tail of X to the head of W. So let's see, this is 1 down and then 6 to the right. So from here, 1 down and then 6 to the right. This is at 3. So this should go all the way to 9. Okay, that's X. And then from our sum vector is going to be like this. All right, and since it is starting at the origin, we can simply look at where the head is, and that would be at 9, -7. Just making sure okay. Okay, oh, it didn't give me, all right, all of those examples had the sum vector starting at the origin. I thought it would give me some examples where it didn't. I don't know, maybe later. So anyway, to add these over here, it's very simple. We're just going to add them component by component. So we'll add the horizontal components together. So -6 plus -1, which is the same as -6 minus 1, which is -7, and then -1 plus 9, which is +8. All right, so that's it. C plus D. So for the horizontal components, we have 2 plus negative 2, which is same as 2 minus 2, which is 0. For the vertical components, we have negative 3 plus negative 2, same as negative 3 minus 2, which is negative 5. So 0, negative 5. Let's do one more like this and see if we get anything different. 9 plus negative 2 is the same as 9 minus 2, which is 7. Negative 9 plus 5 is negative 4. Okay, so these all appear to be pretty much the same. Let's skip to the next level. That's a pretty simple one. This is also the same. Maybe if I do one, it'll be different. So negative 4 plus negative 7 is negative 11. Negative 1 plus positive 2 is positive 1. Okay, that appears to be the same. Let's jump to the next level. If A is equal to negative 6, 2, and B is equal to 4, negative 6, graph A plus B with its initial point at the origin. Okay. So we could put the initial point of A at the origin, and then the initial point of the sum vector would also be at the origin. So let's start from the origin and then go to the left 6 spaces and up 2 spaces, which would put us, oops, I didn't do that very well, but you get the idea, hopefully, over here. And then from here, we're going to go to the right 4 spaces and down 6 spaces. So if we go 4 spaces to the right, 1, 2, 3, 4, and then down 6 spaces, 1, 2, 3, 4, 5, 6, we would end up here at negative 2, negative 4. All right, and then since we started vector A at the origin, then our sum vector, which I'm going to draw in blue now, would also have to start at the origin. Okay, so this would be the sum vector, and since it starts at the origin, the components would be the same as the coordinates. So this vector is going 2 spaces to the left and 4 spaces down, and you can see that the coordinates of the head are also at negative 2, negative 4. Okay, so the coordinates are the same as the components when the vector starts at the origin. What? Oh, so I guess I have to draw it like that. Okay. Yeah. All right. If B equals 8i plus 5j and C equals 7i minus 6j, find the sum B plus C. Okay, so it's just a different notation now. We're just using the I and J notation instead of the angle bracket notation, but we're still just going to do 8 plus 7, which is 15, and 5 plus negative 6, which is like 5 minus 6, which is negative 1. Okay, so B plus C would be 15i, they already put the I in for you, plus negative 1j. All right, if V equals negative 7i plus 6j and W equals negative 2i minus 5j, graph V plus W with its initial point at the origin. Okay, so negative 7 plus negative 2 is equal to negative 9. Positive 6 plus negative 5 is equal to 1. So if I start at the origin, then I would end up at negative 9, 1, like that. Okay. All right, so this is another one we're just adding. Okay, negative 3 plus 8 is 5, and negative 4 plus positive 4 is 0. Let's do one more like this, and then I think we can skip a level. I don't know if we're going to get anything different. So 3 plus negative 2 would be 1, and 3 plus positive 5 would be 8. So 1, 8. Okay. Let's go ahead and skip to the next level. We're up to the challenge zone. Again, find the sum c plus d. I suppose another way that we could do this problem, since both of these are starting at the origin, is we can add the coordinates together, right? And you could only do that if they're both starting at the origin, which they are here. And all the other examples that we have, they started at the origin. So it looks like that's all they're going to give you in this exercise. But just watch out for if the vectors don't start at the origin. In this case, since the head of this vector is at 3, 6, and the head of this vector is at 5, negative 1, we could say 3 plus 5 is 8, and 6 plus negative 1 is 5. So the components of the sum vector would be 8, 5, and then the tail, the head would also end at 8, 5. And you can see that if you just attach this vector to this vector over here, if we go to the right 5 spaces and down 1, let's see, 1, 2, 3, 4, 5, and then down 1, we would end up over here. And what point is that? That is the point 8, 5. Okay. All right, it looks like we've seen problems like this before, so I'm going to end the video there. Have a great day.